Good afternoon, sir and miss, and everyone. I'm Chi Yong, and I would like to share the main result of my assignment and also the demo. So the goal of my assignment is to combine the two defect models we have learned in lab tutorial. The first model is called first order model. This model receives two arguments. First one is the source image, and second is the target video. And the output is the source image will mimic the target video's movement. So it's a video. Okay, in this case, this woman will mimic Trump speaking. And for second model called park segmentation model, I will call it password model later. This model is same, receive two arguments, source image and target video, but the output is different. The output of this model still Trump speaking, but the lips is replaced by the woman's lips. So this is the difference between these two models. One is mimic, one is replaced. And I want to note that the password model not only replace the lips, can based on everyone requirement. If you want to replace the eyes or the nose, also can. But in this case, is lips. Okay. So as I mentioned, I want to combine both of them together. So for example, given the Rock image, John Cena image, and Trump speaking video, I want to generate a final defect video, which is John Cena mimic Trump speaking, but John Cena lips is replaced by the Rock's lips. All right. So let's go to my demo. So the first two steps is click on to the first order model and also the pop swap model. The first order model I refer to is this one. And the second model, password model I refer to is this one. All right. So after I click on to these two model and I take a look, do some let me show you. So yeah, there are many codes in the original function, original demo. So I want to retrieve the important code I needed, and also same for the park swap. All right. Okay. So same for the park swap. I also need to testing and get some important function. Yeah, something like this. So after getting the important code, I will combine them together as one function called fusion. And this fusion function will receive three arguments: source, swap, and video. For example, the swap URL is the rock image, and the source is John Cena, and the target is Trump. So after getting the three input, it will generate a final output defect video. As everyone can see, John Cena will mimic Trump's speaking, and the lips is replaced by the rock. All right. So how can I know the performance of the models? I can download the video and throw into a website. The website has different model for detect the defect video. So the website is here. All right. So basically, you can upload any video you want. I just simply upload an example. So there are four model results. I will only focus on this FIT3183 because the other is quite weak. Yeah, so I prefer focus on this FIT35 model. So for this example, there is 59% probability that this video is a fake video. So I download the John Cena video and detect it. It passed the detection. So there is only 46% probability that is a fake video. All right. So back to the slides. Okay. So after integration, the next step I want to do is try improving the model. And there are two approaches. First approach is to retrain the model. So basically what I want to do is download the original dataset, make some modification and retrain the model. However, the function for downloading the YouTube video is not available now. So if I want to use the function to get the original dataset, it will get an error, which means that the retrain model approach is not available anymore. So I have second approach, adjust the parameter. So both model have lot of file, right? And after taking a deeper look at those files, and I find that in configuration file, there is a parameter called temperature, and this temperature is basically the softmax temperature for chip heat maps. And this is the only parameter that when after I adjust it, it will not lead to error and also can make some difference compared to the original output. Therefore, I would like to do further analysis on this parameter to see whether different value can make the output better or worse. And not that since I combine two of the model, right? The first one is first order model and the second one is pub swap. What I focus more is on the first order model configuration. All right. So before going into the adjustment, I want to explain what is softmax temperature. This parameter represents how confident about the location of key points. So if we decrease the softmax temperature, it will make the model more confident about the location of key points. So may lead to the animation that appear jelly-like because the model's prediction are highly confident, but may not always match the real person movements perfectly. In contrast, if I increase the softmax temperature, the model will become less confident about the location of key points. This can result in the animation that appear more stiff because the model's prediction are more uncertain and may not interpolate between key points as smooth as desired. Okay, so in a simple way to understand, the lower the temperature, the higher the confidence. The larger the temperature, the less the confidence. All right. So back to the demo. Oh, sorry, I need to mention that the original software temperature is shown as this 0.1, and I want to try different value. All right. So I back to demo. Okay. So firstly, I make the temperature become 0.01 and we see the result. So as everyone can see, the John Cena movement is very like jelly, right? Very smooth, too smoothly. And when I download it and throw into the detection model, you can find that it doesn't pass the FIT3183 detection model detection. Suspicious. 60% probability that is a fake video. And how about I increase a bit from 0.01 to 0.05? So it look a bit better than 0.01. So in common sense, we will think that the probability will slightly less than 60%, right? However, the percentage is much more higher, which is 74%. So it's quite interesting discover. What we see is not exactly what the model see. All right. Then how about we let the temperature larger than the original one, 0.15. So as we can see, yeah, it is quite stiff compared to the original one, but not that much. Okay, not that much. And for the detection result, yeah, still doesn't pass. Suspicious. How about 0.2? Okay, is more and more stiff, right? And the result is also suspicious and even higher, 72% to be a fake video. So how about I use 0.09 and 0.11, which is close to the original value. So I just saw the result. For the 0.09 temperature, it still doesn't pass the test, the detection. But for 0.11, it passed the detection. Only 49% probability that it is a fake video. So what I mentioned before, I am focusing on the first order model configuration, right? Let me show. Yeah, here as I mentioned here. So how about we adjust the softmax temperature in the hot swap model configuration? If I use 0.05, suspicious, 0.15, still suspicious. All right. So I only make two adjustments for the hot model configuration. And it's not the main focus. All right. So back to my slides. So I want to make a conclusion. Unfortunately, only the value for 0.11 passed the arbitrary file detection model. However, the original one, 0.5, is still the best because the result is 46% probability to be a fake video, which is less than the 0.11. But in another perspective, at least I find a value still pass the detection. And not only this like that, in the error I made before, which I didn't show because already error, I learned quite more knowledge from another parameter. And the softmax temperature is the only one parameter can be adjusted without leading to any error. So this is my conclusion. Thank you very much.